So a PySpark. So I'll be discussing the following things, right, as part of this PySpark demo. Like, what is Apache Spark? Why PySpark? Need for PySpark. One second. Generally, people ask, right, Spark implementation. We have got two major programming languages like Python and Scala. Which one is preferred, right? Spark with Python, Scala. PySpark features. PySpark features. And real life usage, right? A real life usage of PySpark. PySpark job market. PySpark job market, right? Yes. Fine. This is what I'll be discussing as part of today's session, right? What is Apache Spark? Okay. Apache Spark. You can say like it is an open source. It is an open source, right? Distributed cluster computing. Distributed. It is an open source distributed cluster computing framework, right? It is an open source distributed cluster computing framework introduced by Apache Software Foundation. Open source distributed cluster computing framework introduced by Apache Software Foundation. I can say it is a general engine for big data analysis, general engine for big data analysis, processing, and computation. If you talk like why PySpark? Why PySpark? PySpark is the Python API, is the Python API, right? It is a Python API to use Spark. It is a Python API to use Spark. So I said PySpark is an open source cluster computing system used for big data solution, right? I can say PySpark is one of the lightning fast technology that is designed for fast computation, right? Yes. It's a lightning fast technology which is designed for, right, for fast computation. How this computation and what is the execution model, everything I'll be discussing in brief. Okay. It's PySpark is one of the very demanding tool among the data engineers, right? To work with the bigger data sets for huge data rates and processing it a quick rate of time, right? Generally, like why PySpark is used for? Why PySpark used for? Running distributed SQL, running distributed SQL, what? Creating data pipelines, creating data pipelines, right? Ingesting data into database, right? Ingesting data into database, running ML algorithms, machine learning algorithms, right? So we have got a separate module in the PySpark ML for running SQL queries, right? Like Spark SQL is there, and for machine learning, Spark ML is there, right? For data streams, right? Like Spark streaming is there, and we're working with the graphs, working with graphs. Spark graphics. For the Spark graphics, we have got. For this Spark streaming, we have got Spark ML, Spark SQL, right? For running distributed SQL, for creating data pipelines, for ingesting data into database, for running machine learning algorithms, for data streams, working with graph algorithms, right? Yes. Fine.
Vijay, this PySpark is not a module. It is an API from the Apache, or it's kind of a package or module.
One second. Spark is an execution model, right? Spark is an execution model. Which can be coded with, which has multi-language support, Hence, I can say Spark can be coded with Scala language, Python language, Java language, or language. So Spark is an, see, previously Hadoop MapReduce execution model, what? But now in the industry, that MapReduce got outdated. Now everyone, they are using Spark execution model. Hadoop for storage and for processing. For processing, MapReduce previously, but now for processing, we are going with Spark execution model. But it can be, coding can be done. The Spark execution model coding can be done in Scala language, Python, Java, and OR language. Mostly used Scala and Python. Python and Scala are the mostly used languages for Spark implementation. Spark with Python, right? Python, PySpark is here, right? Like it is an API. PySpark is an Python API for using Spark. So it is providing many built-in, but that what all that behavior Spark functionalities is going to remain same, right? But only the implementation coding will be changed. But Spark by default built using frankly speaking, right? Like Spark by default built by using Scala language. Spark was built using Scala language, right? But in the earlier days of Spark, right? Like if you see in 2015, 16, 17, mostly Spark implementations were done in Scala language. Now, from the last 3-4 years, especially, right? Mostly in the industry, they are preferring Python because of Python has got many modules. 89,300 modules Python is supporting, especially for environment like ML, machine learning. Python has got separate modules it is providing, right? Like NumPy, Pandas, CP, scikit-learn, like many models it has got for. So Python has got great libraries for machine learning. That's why Spark, especially for implementing this machine learning library, right? Apart from machine learning for normal other things also, Python has got great modules. It has got many modules for it, right? So like Python is mostly used, even Scala also used. I'm not saying that Scala is not used. Even Spark can implement it by using Scala. Scala is similar to Java only. It is a scalable language. Scalable means extensible. Extensible means like Java extended by Scala language. But Java has got only object oriented, but scale, okay, I'll differentiate this, right? Java has got only object oriented. Without object oriented, you cannot write a Java application. But we talk in Scala and in Python, multiple properties you have got. Multiple features, right? Multi-programming features. In Python also, it supports procedural oriented, object oriented, scripting. Here also, Scala also object oriented, procedural oriented, script based. But as compared with Scala, Python has got modular programming, which you won't see in Scala or in Java. In Java, only object oriented, but here in Scala and Python, we have got multiple programming features. So currently, right, Scala and Python are mostly used for implementing Spark execution, right? The implementation totally goes in Python or Scala. So by default, it is built using Scala, right? Okay, fine. I'll come back to this, right? I'll be discussing more on this, comparing Spark with Python or Scala. But before that, what is the need for PySpark? Need for PySpark, right? Yes. So generally, if you see, huge data is getting generated. Huge data is generated, right? That is online and offline. You can see huge data is getting generated. The data which is generated has got many hidden patterns are available, market trends, the user preferences, right? And unknown corrections, and many other useful business information, right? We need to extract some valuable informations from this raw data, which is of huge data, right? So we need to have some efficient tools to perform these things, right? There's many operations on this huge data, big data, right? So there are some various tools to perform this multiple tasks on this. Previously, we have got some tools available. I don't say that it doesn't have any tools. We have got some tools, but the tools are not so appealing, right? So it is, so we require some scalable and flexible tools, right? To crack this big data and gain some benefit from this huge data. So PySpark is such a kind of technology, right? So at a very rapid speed, it can process the huge data. So, and it is going to extract the valuable information from the raw data, right? So, combination of Python and the Spark, combination of Python plus Spark, right? Is the very efficient way for the world of big data, right? Python plus Spark. So that's why Apache Spark community came up with a tool called PySpark. It is an Python API for using Apache Spark. PySpark, right? Yes. So if I differentiate, like most of them, even if they ask, right, should I go with the PySpark with the Scala implementation or Python implementation, right? Just observe this. If you go for Python or Scala, the mostly used. If you Java is not preferred, but very less companies they prefer Java, but because of this huge codings in Java, right? So not preferred. Now, you see the difference, right? Python is dynamic typed. Dynamic typed. This one. Static type. Python is dynamic type. Scala is static type. Dynamic type means generally here, dynamic data types we say in Python. So if you assign some value 10, so directly X is what variable means integer variable created dynamically as you assign an integer variable directly it takes integer type, right? Dynamic type. Yes. Based upon what value you are assigning, if you're assigning a list in Python, if you're assigning a list, right? So it is going to take the type of X will be list. What kind of variable X is means list. Why list? Because you assigned a value, list value, right? So based upon what value you are assigning, based on that, the variable is created dynamically here in Python, right? That is dynamic, but scalar we need to specify, right? Val or var. Okay. Uh, Second, Python contains powerful libraries, right? For ML, comma, graph algorithms. Python contains powerful libraries. Python contains powerful libraries, right? For ML graph algorithms. Scala has got, but as compared with Python, it is less. Python, Python has a huge community, Python has a huge community, and it has got thousands of modules, 89,300 modules. But Scala also, Scala has an excellent community, but lesser as compared. Has many applications, has many applications used for different environments, for data, big data environment, data science environment, for automations environment, for web applications creations, has many applications. Only for Spark environment, only for Spark environment, no other environment using this Scala language, right? It is the native language of Spark. Scala is the native language of Spark. But Python is good, but here Python, frankly speaking, Python is slower. Scala is faster. Scala is faster than Python because in Scala it is interpretation, line by line execution. But in Scala, right, it entire code it executes at once, right? Yes. Understood, right? So Python is dynamic type, contains powerful libraries, has got huge community, has got many different types of applications, right? But only one thing is it is slower as compared with Scala, right? Yes. Talk about the PySpark features. PySpark features, right? Yes. Main feature for PySpark. Very high speed, for example, in-memory computation. In-memory computation, right? Yes. In-memory computation. Means very high speed you are going to see, very high speed. Both, both storage and processing, both storage and processing it the memory level, right? Both storage and processing at the memory. In memory computation, both storage is happening and processing is happening within the memory level, right? Yes. In memory computation. Lazy evolution. Lazy evolution, right? Lazy evolution means we have got active evolution, lazy evolution. Active evolution means whenever it is defined, immediately executing. Whenever, right? Whenever defined, immediately executing it. But there is a concept like functions, right? You know, functions. It won't execute immediately. Whenever you make a call only, it executes. It is lazy evaluated. If you make call only, execute. Otherwise, just like a labor example, you are writing notes. It doesn't mean that you will immediately go and read that notes. Whenever exam is kept, then only you will read. Whenever exam is kept before the day of that exam, right? You will be reading. That is lazy evaluated. Immediately, the same day, if you are reading, is active evaluation. But for 1 month, you won't read. Just before the exam, if you read, that is what lazy evaluated means. On required, on whenever on demand to execute the flow, right? The data flow, entire data flow gets executed on demand. That is what lazy evaluation, right? On required or on demand executing the flow execution, right? Data flow will be executed, right? Yes. On demand executing the data flow. Until then, it won't execute. Until then, it won't execute. On demand executing the data flow. Until then, it won't execute. That is what lazy evaluation. More on this, I'll be discussing with multiple examples during this competition of this PYSPARK. How this is going to be. Next, one more. Persistence. Persistence feature. PySpark has got a feature called persistence. Reusing already executed. Reusing already executed transformation. Reusing the output. Reusing the output of already executed transformation. Persistence feature. Again, you no need to re-execute. Again, no need to start from the beginning, right? So already executed transformation results you can reuse, right? Reusing the results of already executed transformation, right? Yes. And we have got one more, like Spark has got a very, it's a fault tolerant model, right? Powerful fault tolerant model. Fault tolerant. Powerful tolerance, powerful fault tolerant model, right? See, generally, the Spark data objects are divided into smaller parts. They are going to get distributed on multiple RAMs of multiple worker nodes and are executed parallelly. That's how, because of which has got a very high speed. Means the Spark data objects divided into smaller parts distributed across multiple RAMs of multiple worker nodes and are processed parallelly, because of which very high speed, because of this in-memory computation. But as it is distributed across multiple systems and processed by multiple systems, if any system goes down, right? If any systems goes down, then Spark has got the capability of regenerating the lost data and can compute it, right? This powerful fault tolerant model. So I'll be discussing with multiple examples like different cases, like multiple cases, case one, case two, multiple cases. I'll be discussing about this fault tolerance. Immutability, right? Whenever you are making any transformation on a particular data object, whenever you're performing, the original data object will be immutable. It won't be modified, but a new thing is going to be created. A new object will be created from it. The whatever the available object, you are not going to modify. It is immutable. It can't be modified, changed. But from the same object, you will perform some transformations or filtering or grouping or merging or sorting, any kind of operations you perform, right? And a new object will be created, but that original object, it won't be modified, right? Yes. And one more, like if partitioning, right? Partitioning, right? Partitions, so that Spark data objects are divided into partitions. If the partitions only, then they can be distributed across multiple ramps of multiple worker nodes, right? Yes. So in-memory computation, lazy evaluated, persistence, fault tolerant, immutability, partitioning, right? Yes. So about all this, I'll be discussing in brief, right? Just given an overview on this PySpark mainly, right? In-memory computation, the main feature of PySpark. If I talk about where exactly this is used in our real life use cases, right? A real life real life use case of PySpark. One second, sorry. A real life use case of PySpark. First one, in commercial sector, right? In commercial sector, PySpark is used, especially, right, for real-time processing. For example, like banks and other financial systems, financial fields are using Spark, that is PySpark, right, to retrieve the customer's social media profile and analyzing to gain useful insights to help them to take the right decisions, right? Commercial sector, right? You have Apache Spark real-time processing. The banks and other financial fields are using Spark to retrieve the customer's social media profile, right? Yes. So this it can be used in credit risk assessments and also in fraud detections. It is widely used in that, right? And apart from this, in healthcare also, right? In healthcare also today, if you see like PySpark plays a vital role when identifying the patients who are going to face the problems, who are going to, since it is a kind of predictions it can be doing. It going to identify the patients who are going to face the issue even after being discharged, right? And even in the entertainment industry, right? The popular OTT platform, the popular everything that if we talk about the total industry is moving towards this online, right? Online streaming. The popular online entertainment platform Netflix using Apache Spark for its real-time processing for this personalized online movies or web series. It processes approximately 4 450 billion events per day. Right. Even for this trade and e-commerce, for e-commerce, right? The leading e-commerce websites, Flipkart, Amazon, all these, they're using this Apache Spark for advertising purpose. These websites, okay, they offers enhance customer experience and optimizes the overall performance. Even even if we talk like tourism industry, right? Yes. It there uses Apache Spark to provide advice to millions of customers by comparing hundreds of tourism sites, mostly used in this commercial sector, in entertainment industry, in healthcare, e-commerce. These are some of those examples where they are used, right? Yes. Job market of the PYSPARK. Okay, you can check it, right? When you can Google and check PYSPARK. As data is increasing, data is growing, right? So for huge data processing, this is the one of the efficient tool in the industry, right? For processing huge data at a quick time. When you can see that job packages and the salary packages for this PYSPARK as compared with the other technologies, right? Huge job packages for this PYSPARK people. So in the same way, you need to have great command on this technical skills of this PySpark. So as part of the course, I'll be discussing in brief, in depth, point to point about all this, each and every functionalities. We have got many built-in functionalities given by PySpark, right? When from data frames, many functionalities provided. We no need to write huge tasks, but perform these operations. Just you need to understand what output you are going to get when you apply any particular functionality, right? As a data engineer, right? As this PySpark developer, whenever you apply any functionality, what functionality to be applied, and if I apply this functionality, what output you are going to get, everything you need to know. For that, you need to have good command on this each and every functionality and the behavior of this PySpark. So what I'm going to discuss as part of this PySpark, you can just check this in brief, in depth. I'll be discussing about all this. 1 second. PySpark, right? PySpark introduction, like what is Apache Spark, why PySpark, need for PySpark, compared with Python and Scala, real life usage. What is PySpark sessions, PySpark context, parallelizing, broadcast variables, accumulators, right? And PySpark RTD computations and persistence options and the core computations, right? Fault tolerance, different ways of creation of RTDs, increasing the number of partitions and groupings and aggregations, single grouping, multi-grouping, single aggregations, group by key, reduce by key, various different inbuilt actions and transformations of PySpark, count by key, count by value, sort by key, union, distinct. In this way, different joins, partitions, different many functions like for actions and transformations it is providing. And if you come to this PySpark SQL data frames, right? Many we have got data frame functionalities, creating data frame, empty data frame to pandas, row class, column class, select, collect with column, column rename, drop, order by group, join, union. We have got many functionalities in each and everything with some working examples I'll be discussing. And PySpark SQL functions, aggregate functions, window functions, data and timestamp functions, JSON functions, read and write JSON file. And PySpark inbuilt functions when a split, substring, translate, overlay, to stamp, to date format, months between, select, map keys, map values, struct, in this way, all this, right? And PySpark external sources working with SQL statements with Hive integration, with MySQL integration, working with CSV, JSON transformations, actions on data frames, narrow and wide transformations, adding new columns, dropping columns, handling nulls, window functions, yes, and the deployment modes like local mode, cluster mode, applications, PySpark applications, creations, right? States and task drivers, executors, building Spark applications, pipelines, deploying Spark applications to cluster and tuning, performance tuning, right? And PySpark streaming concepts, integration with Kafka, right? And PySpark machine learning library. This is what the entire course, right? In brief, in depth, we'll be discussing about all this. Yes. 1 second. Yeah, just before you go with the queries, right? Yes, just 1 second. So timing of this batch, 5:30 p.m. to 7:30 p.m., right? On Saturdays and Sundays, every week. It's a weekend batch. It's a weekend batch, right? 2 hours on Saturdays, 2 hours on Sundays. 10 weekends. it goes to 2.5 2 months, it goes, right? 10 weekends, 8 to 10, you can say like 8 to 10 weekends. And you will be getting the session recordings, session video. Yes. Soft copy of the class notes. A separate WhatsApp group for this PySpark. Separate WhatsApp group for this PySpark you get, right? Tasks to work with. And all the sessions will be you will be kept in unmuted status. You will for each and every statement type, you will be responding with that result, whether it is correct or wrong. And whenever you get any query, immediately you can unmute and you can ask the query, right? Interactive sessions, right? Yes. Yeah, someone was asking some query, right? Yes. So each and every session video you will be getting. The session video you can play and you can watch it even if you miss any of the session because of some ill health or because of some office work, unable to attend, you can just go through that and attend the next session, right? You can only play and view the videos. You cannot download it. Yes, class notes, WhatsApp group, right? Yes, yeah. Someone was asking a query, right? And before that, tomorrow everyone can attend the session, same time at 5:30. To see more on this PySpark, right? The computations of this PySpark. Yes.
Yes, Vijay.
Yeah.
Can I ask now?
Yes.
Okay. So the simple question is, so this PySpark can be used for both the transactional system as well as act as a analytical system like a OLAP and OLTP.
Say one thing, this Hadoop Spark is for batch processing, not for OLTP processing, not for online processing, right? So just for batch processing only,
Batch
analyticals
processing.
only, right? Not for batch processing only, not but for analytical processing only, not for online processing.
Okay,
Say
no.
for one record, two records, three records, Spark is not used, right? So for millions and trillions of records for huge data, right? And for processing that huge data, Spark will give the better results. But for a small data, for one transactions, two transactions, right? If you're making a query and SQL query in Spark and in Oracle database, both will give the same result, right? Same time it takes. So for huge data, if you compare both, right? If we are querying in Oracle database or if we talk in Spark SQL, if we are doing, so this processing will be at a very high rate of speed. It is going to process, right? In the case of Spark. So that is for a single one record, two records for small data, right? These things are bad.
Okay. And what I mean, see, use it for data streams means can you give me some context on that? Data streams means is it
Streaming,
like
streaming,
huh,
streaming data, right?
yes,
So data
live,
which
right?
keeps on, yeah,
Huh.
live streaming data. So data which keeps on generating, data which keeps on incrementing, right? Such kind of data capturing. But in the case of Spark streaming, right? This for micro batching, for every 1 minute, I want updates. I want to just to process the data and immediately providing the results for it. At one side, right, the events keeps on generating. At the other side, it should keep on processing. The rate of speed the events are generated, the rate of speed the events has to be processed. So we need to have some efficient, very fast technology at the rate of, for example, in a 1 minute, 1 lakh events got generated. But 1 lakh events to be processed in a minute, right? We need to have a technology, right? The Spark is such a kind which can means if you creating micro batches and providing results updates for every 1 minute. Micro batch means batch and micro batch. Batch means for huge for 1 day or 1 month, or if you take micro batching means for every minute I want update for
Yeah, near
every
real
five
time.
minutes.
Yeah,
Yes,
yeah, near
got
real
it.
time. So okay, that in that case, exactly where we, I mean, can you give me the some scenario about near real time kind of thing? So where we use the PySpark in that case.
Where PySpark you are using, your PySpark is used, you are saying
I mean,
where the PySpark is preferred.
yeah, near real time use case. Okay, yeah, so that I want to understand actually.
So for example, okay, even PySpark has got it is providing ML library, right? Machine learning libraries. So if you have seen example I'll show you. In your Flipkart, whenever you purchase a product, it is giving a some kind of recommendation. People who purchased it also purchasing other products. I said in PYSPARK real life use cases, right? Here it is also used in e-commerce, especially for Flipkart and Amazon, all this kind of recommendations it is providing, right?
But those are near real, not near real time data, right? So it is already model, okay, already exists pre-trained, then only it will be deployed on the prod system. So it's kind of a batch. It's kind of a batch applications, right?
For example, you purchased a product. Now you have purchased a product. Immediately it is giving some recommendation, right?
Yes.
Immediately it is giving a kind of okay. If even I said about the commercial sector, so real-time processing means, see, 3 days back some transactions happened. 3 days back or 5 days back transactions happened. Now you are detecting a fraud has happened. But here in the case of Spark real-time processing, right? Immediately detecting the fraud has happened, detecting the fraud detections, right? Yes.
So which platform are we going to use to practice this PySpark, or like AWS or Azure, and which platform?
So just I'll be showing you on the on-premises, right? And that the last time I'll also be showing you on the Azure platform, right? Databricks. So on how this PySpark is going to be executed on the cluster, right? On the Yarn cluster, especially like we are using a Hadoop cluster, right? How to run this within the Hadoop cluster, Yarn cluster on premises and also on cloud premises. At the last I'll be showing you on that.
Okay.
Both premises, right? On the on premises and on the cloud premises, right? And cloud premises means I'll be showing you on Azure, right? That is in Databricks.
Okay. Databricks is a PySpark, Vijay, or it is I mean, on top of PySpark, they have their own flavor on that.
The Databricks is that it is going to provide a kind of cluster. It is going to provide some kind of Spark cluster, right? So for performing these operations.
Okay. Just a cloud platform to run the kind of a PySpark jobs.
Yes, PySpark jobs.
Okay.
Spark jobs. We can say Spark jobs, not only PySpark jobs, Spark jobs. It can be any language, right? But in the case of so it has got Databricks has got support to any of the cloud, not only for this. AWS has got, Azure has got, even Google has got this Databricks, right? The general Databricks it is providing support, but even if you take any of this Azure, or it is providing support to all the cloud systems, right? Yes,
yeah.
But there is limitation for some of the languages, like Azure doesn't support Spark with Java, it won't support. But Spark with Python, it supports. Spark with Scala, it supports, right? So in the industry currently, like Spark with Python is mostly preferred, right? Where Python is a hybrid language, where it has got multiple programming features widely used for different purposes, right? So because of which PySpark and Scala both are preferred. I'm not saying only PySpark is preferred. Spark with Python, even Scala is preferred. But in the both are right. But the Spark execution model going to remain same, right? Means whatever the behavior you are going to see, the functionalities you are going to see, right? Which remains same, right? But only the implementation language will be changing, right? Fine.
Sir, question.
Yes.
Sir, PySpark is used for real-time data processing, right? So when should we use PySpark and when should we use Kafka? I mean, Kafka is also for real-time processing, right?
Yes. Kafka is not for that, right? Kafka is for capturing live streaming data. Live stream Kafka is going to capture the live streaming. We have got Flume and Kafka, right? They'll be acting as data ingestion tools. They keep on capturing the events, and also they'll be dumping the data to the target systems, right? For Kafka is for purely for live streaming, they're capturing live streaming data, capturing of live streaming data, right?
Okay, live streaming. Kafka is for okay. Thank you.
Flume and Kafka components have got. Even I said I'll be giving knowledge on this Kafka.
Yeah,
right?
yeah, sure.
Kafka, like
Thank
capturing live streaming, and Spark streaming is there, right? Spark streaming mostly used for micro batching for the updates. Micro batching means for quick results for not for a huge amount of time, but for a particular time, right? How many events are generated immediately processing and giving the results.
Okay.
Okay, fine. Tomorrow also we'll discuss more on this. So everyone, same, you can follow the same timing, 5:30 p.m. tomorrow, using the same link to see more on this, right? So tomorrow I'll be just briefing you about more discussions, in brief discussion on this. Nice, fine. So if I'm done with the queries, if there are no other queries, I'll just sign off for now. Meet you tomorrow at same time at 5:30, right? It's fine. Thank you all. Meet you tomorrow. Bye.
Thank you.